Hi, everyone. Welcome to Foresight's Intelligent Cooperation Group. I'm so delighted today to have Aslan Satary Dizaji here, and he has quite of a mouthful of a presentation to give. The talk title is A Multi-Agent Reinforcement Learning Study of Evolution of Communication and Teaching Under Libertarian and Utilitarian Governing Systems. So I'm really excited for your presentation. Thank you so much for joining. I will share a lot more about you in the chat here. And with that being said, without further ado, please take it away.
Okay. So thanks for invitation. So I am going to present the projects which I have done during the last 2 years. Basically, I was using multi-agent reinforcement learning to simulate social phenomena. I did this kind of project under the title of AutocurriculaLab, which is just the name which I gave to these works. And so let's start. There are three projects which I did under this title. And the first one is multi-agent reinforcement learning, a study of libertarian and utilitarian governing systems. The second one, multi-agent reinforcement learning, a study of emergence of social classes out of arbitrary governance, the role of environment. And the third one, a multi-agent reinforcement learning, a study of evolution of communication and teaching on the libertarian and utilitarian governing systems. Basically, these are open source projects. The code and the papers are available. And I am going to present each one of them briefly in the next slides. So I guess, okay. This is the first project, a multi-agent reinforcement learning study of a libertarian and utilitarian governing system. I had two main questions under this project. Basically, I wanted to know what is the effects of institution on the morality of the agents of the society. I wanted to know that what kind of moral values would be the product of a society governed by libertarian passive central planner, or, for example, a utilitarian active central planner. So there's a kind of widespread hypothesis in the literature that says that there is a, for example, co-evolution of institution and culture in a society, which argues that liberal inclusive institutions are more prone to generate large-scale pro-social norms compared to, for example, more extractive or arbitrary institutions. Then in the second question, I wanted to know what is the effects of institution on prosperity and equality in a society. So basically, I wanted to know which governing system is more, it is able to generate more prosperous society or more equal society. So this was, again, for example, there is a literature around this topic that, for example, the democracy causes economic growth, but at the same time, there is a kind of mixed result about what is its effect on the equality. So this is the second question which I wanted to test. So all three projects which I mentioned in the first slide, they were done by extending a multi-agent reinforcement learning framework, which is called AI Economist. It is a kind of recently developed framework developed by Salesforce. And it is here, I use it mostly for the purpose of simulating population of agents. So it is a two-level order for two sets of agents, the mobile agents and the central social planner. It is originally devised for tax mechanism design. I use this feature of this framework, tax mechanism design, but I extend it further. Then the game is a mixed motive, partially observable stochastic game with simultaneous cooperation and competition. The agents share weights in the centralized training and decentralized execution by having their own sets of weight. These are just technical terms, not that much related to the main results of this project, but I am just telling them. In this environment, there are two material resources for collecting, trading, and building houses. There is one house type. That house is going to be built based using each unit of these two material resources. There are 2 to 10 mobile agents in the environment. There is one central planner with various social welfare functions, And the final taxes, which is going to be collected by the central planner, is going to be distributed evenly among the agents. There are basically on the in the top plot, I just showed the kind of, for example, a schematic picture of what is happening in this game. And also on the blue, that there is, for example, there are three different actions each one of agents can take. For example, there is a move and gather. They can move in the environment. They can gather and collect the resources. They can trade the resources with each other, and they can build houses. What I did for the first project, I extended this framework. Basically, I did a few, let's say, minor kind of modifications. One major modification? The minor modifications was about, for example, instead of 2 material resources, now I have 3 material resources in the environment. Then using these 3 material resources, the agents can build 3 different house types, each one built from 2 out of 3 material resources. Then I use 5 mobile agents in the environment. Then the major extension of this framework is that I added one voting mechanism into this environment. And by voting mechanism, I let the agents to basically rank, to basically be able to rank and vote different material resources that they have based on their own views. For example, they can say that, okay, I prefer wood compared to stone compared to, for example, iron. This is something which is going to have effects on how to invest, how the central planner is going to invest the collected due taxes on these material resources. So based on this voting mechanism, there are 3 different governing systems. In the full libertarian governing system, the central planner is going to set the tax rate, of each individual agent. Then the agent is going to individually decide how it is going to rank the material resources. And after that, the agent individually is going to invest the material resources based on their own its own view. So this is the full libertarian case. There is a list, let's say, the central government has list how power can impose on the agents. Then in the semi-libertarian utilitarian case, the central planner is going to set the tax rate. Then the agents are able to vote and rank the material resources. But what is happening is that the central planner is able to count the votes of the agents, and based on the counted votes, is going to invest the total collected due taxes of the agents on the material resources. And the third one, in the full utilitarian case, basically there is not any direct voting mechanism. The agents are not able to vote. Only the central planner is going to decide how to rank the material resources. And then after that, based on the total collected due taxes, it is going to say that, okay, I am going to invest this amount of money on these different material resources. So I call these 3 different governing systems. There is a spectrum across individualistic, collectivistic arcs. The full libertarian case is more individualistic governing system, and the full utilitarian case is more collectivistic governing system. Then, in the semi-libertarian utilitarian governing system, I further divided this governing system to 3 different governing institutions: inclusive institution, arbitrary institution, and extractive institution. And how I define them, for example, in the inclusive institution, all the agents' votes are going to be counted equally by the central planner. Under the arbitrary institution, randomly selected number of agents, the votes of randomly selected number of agents is going to be counted by the central planner. For example, only 60% of the agents are going to be counted. Then in the extractive governing institution, the votes of the most wealthiest agents, the votes of those agents who, for example, earn so much coin during an episode is going to be counted. And for example, top 60% of the agents is going to be counted. I call this a spectrum from inclusive, arbitrary, and extractive governing institutions. I call this discriminative box. Basically, the inclusive state is less discriminative, and the extractive one is most discriminative governing institution. Then, the final total taxes are going to be invested on the material resources as by the governance, as I explained. So, in this environment, basically, I added one vote and invest action to the other actions by the agents which they were able to do. So this is just one, let's say, schematic picture which just shows what I mean by individualistic collectivistic ox compared to the discriminative ox. Individualistic collectivistic ox, the central government has it is based on the central government decision power. If it has less decision power, it is more individualistic. If it has more decision power, it is more collectivistic. And then discriminative ox, that's, for example, how the agents are going to be treated by the central government, if they are equal in front of the central government or if they are not equal. So then the results for the first question, the effects of institution on morality. Before I bring the results, here I just explain briefly the model that I use as a simple model for morality. So let's assume that there are two persons. Then let's assume that someone gave, for example, 1 coin to one of the persons and 5 coins to other person. And from the person who has 1 coin, the experimenter is asked that, okay, how much you are going to give to the other person who has a 4 coin. Okay, you give 2 coins to one person and 4 coins to other person. Then the experimenter is going to ask that, okay, how much the person who has 2 coins is willing to give a coin to the other person who has a 4 coin. Probably if the person is somehow, for example, it feels that it is unfair to itself that transfers some amount of coin to other person who is more wealthier. Inequity aversion here means that you feel that you should be treated equally as the other person, and you would feel that you shouldn't be unfair to yourself. So this is the kind of disadvantages in equity aversion. Then simultaneously, we can just assume different condition. In this condition, the decider is going to have 5 coins, and the recipient is going to have 1 coin. And then the decider is going to transfer only 1 coin to the recipient. Again, this is a kind of, let's say, unfairness to others, because you are more wealthy. Why you don't transfer more coin to the recipient? This is a kind of advantages in equity aversion. So this in equity aversion is a simple model in economic, which is going to use in this kind of condition to show that, for example, how much people are advantageous in equity aversion or disadvantageous in equity aversion. In the framework which I use, in the bottom plot, basically there are more complicated interaction between the agents. So for example, one agent, maybe she has, for example, 94 coins, and then she asks that, okay, I would like to sell 1 unit of a stone in exchange of 5 coins. Then the other person maybe has 65 coins, and then it says that, okay, I want to bid, I would like to buy 1 unit of a stone in exchange of 4 coins. But there are many kind of interactions like this. Above example, just what I want to say is that the above example just a simplification of the actual happening, which is actual events which is happening in this environment, but can be modeled by this simple model, by this simple formulation, which I bring here. So if you just assume that U is the subjective utility of one event or one action, and R refer to the actual reward, the subjective utility of, let's say, one event or one action is less than its actual reward, because the person is going to evaluate also its, for example, the person is going to evaluate that if, for example, this interaction is disadvantageous in equity averse, or it is advantageous in equity averse. Based on its evaluation, it is going to attribute different amount of subjective utility to one event, to one action, probably less than the actual reward. These are the first result which I obtained, which I would say that probably they are not that much surprising. Basically, I could show that the number of here alpha refer to the disadvantages in inequity aversion coefficient, and beta refer to advantages in inequity aversion coefficient. If they are higher, it shows that the agents are more in equity. If they are higher and greater than 0. So for the first result, I could show that in the full libertarian case, which the central government has less power, basically the number of non-zero alphas is greater than the full utilitarian and then semi-libertarian utilitarian cases. So this is somehow shows that in the full libertarian case, which, for example, the agents are, let's say they can behave in a way that they want. There is going to be more moral and fair agents in the environment. And again, about the betas, I obtained the same result for both alphas and betas. Alpha refers to the disadvantageous inequity aversion, and beta refers to advantageous inequity aversion. In both cases, under full libertarian governing system, we have more moral and fair agents compared to the full utilitarian case. So then this is basically what this was about the spectrum of individualistic collectivistic arcs. And now about the discriminative arcs, again, I found this result that, for example, under inclusive institutions, the agents are more fair and more moral compared to, for example, extractive or arbitrary institution. But one surprising, maybe surprising result is that arbitrary institution even worse than extractive ones. For example, when the central government it just behave randomly without any kind of binding rule, the morality or the fairness of the agents are going to be worse and worse. Now, the second question, the effects of institutions on prosperity and equality. Here, what I obtained. So the top rows show the plots for productivity, equality, and maximum for 3 governing systems: full libertarian, semi-libertarian, utilitarian, and full utilitarian. Then we start with equal initial endowment. And the bottom row show the same plots, but this time with unequal initial endowment. So what I obtained here is that under full libertarian case, basically the blue lines, we have more productive society. We have a society with higher maximum, but we have less equality. And again, this is the case when we consider the bottom rows, that the bottom row, when we have the environments, when it starts from initial unequal endowment. So again, the full libertarian case generates more productive society, more society with higher maximi, but with less equality. So these are, again, probably not that much surprising. Here, when we come to, for example, discriminative arcs, the productivity, equality, and maximum, again, in the top row, it shows that the 3 plots on the top shows that under inclusive institution, we have more productive society, we have more equal society, and we have a society with higher maximi. Again, for example, I would say that this kind of equality, maybe it is a kind of surprising result. But again, I believe that it is somehow also matched with what we observe in the literature, that under inclusive institution, we have more equal, let's say, society. And the bottom row also shows the same trends. So this is the first project. So I am now going to explain the second project, which is more related to this situation in Iran. Basically, what I forgot to say that I am from Iran and I am based in Iran. The second project is more related to what is the condition in Iran. A multi-agentic possible learning study of emergence of social classes out of arbitrary governance, the role of environment. There are, let's say, two frameworks about long-term economic development in a country or in a region. So the first framework, under the first framework, we could see different theories about long-term development in a region. And these different theories are based on different hypotheses. For example, geography hypothesis mentions that the reason that one country is poor is because its geographical location, because of, for example, its natural resources and other, let's say, kind of thing which is related to geography. Then the second hypothesis, cultural hypothesis, mentions that the reason that one country is poor and one country is wealthy is that because of the ethnicity or because of the religion or because of the culture of that society. The third hypothesis mentions that basically ignorance hypothesis mentions that the reasons that, for example, one country is poor and the other country is wealthy is that the leader of the country which is poor does not know how to lead the country. But the leaders of, for example, those countries who are, let's say, more prosperous, they know how to lead the countries. And finally, the last hypothesis, the institution hypothesis, which is basically mostly around the works by Daron Ajamoglu and colleagues, it says that basically the man-made institutions, those institutions which are built by humans, political or economical institutions, they are the reason for that some countries are more wealthy and some countries are more poor. And for example, some institutions, for example, motivate the people to work harder, and some institutions are just not that much, let's say, because they are not inclusive. They don't build the kind of, for example, the flourishing environments that, for example, the agents can flourish and can be more productive. Then there is one specific theory about long-term development in Iran, which is called arbitrary rule and arido-solatic society developed by Homa Katuzian. This theory can be framed an instance of geography hypothesis, which I am going to explain in the next slide a little bit more. So under this theory, it is mentioned that in Iran, the state is the only functional entity of the society which is completely independent from all urban social classes. There is not any functional urban social class which its identity is independent from the state, while there is a large body of laws, but due to lack of functional urban classes, there is not any non-violable binding rules between the state and the society, which makes the government essentially arbitrary. Then Katuzian attributes the emergence of the arbitrary governance to the aridity in the vast region of the Iranian plateau. The aridity generates a large number of small isolated villages, which their individual surplus is not sufficient to found a feudal base, but the sum of all surplus of these villages could make an arbitrary governance with large infrastructure in urban areas. Then, the arbitrary rule could make all urban social classes dependent on itself while it perpetuates its power across country until that point that some internal or external conditions ignite revolution. At this point, since the arbitrary governance is independent from any social classes, all urban classes are less or more against the government. So basically, the essence of this theory is that when we have, for example, here I tried to model this theory using the AI economies. On section A, that I modeled this environment by assuming that, okay, when we have, for example, this kind of isolated patches of natural resources in the environment, we could say that this environment is more similar to what mentions in his theory. That this is more, let's say, the natural resources are not uniformly dispersed across the environment. So this is the section A. And then in the other environment, the natural resources are dispersed equally and uniformly across the environment. Section B. So then, just based on these, the other thing which is important to say is that the total amount of natural resources in both environments are the same. So the only differing factor between these two environments is that in one of them, in A, the natural resources are placed in isolated patches, but in the other one, the natural resources are just uniformly distributed across the environment. So again, there are 3 material resources for collecting, trading, and building houses. 3 house types, each one built from 2 out of 3 material resources, just like before. And there are, I consider only 5 mobile agents. And then there is one arbitrary central social planner with various social welfare functions, which I'm going to explain this central social planner in the next slide. And the final taxes are going to be distributed arbitrarily across agents by the arbitrary central social planner. Arbitrary central social planner can have two different factors can contribute to one arbitrary central social planner. The first factor is that just a randomly pre-selected number of agents are going to be considered by the central planner. So the amount of taxes, the amount of total collected due taxes by the central planner is going to distribute it among these agents. So by the first equation, I just tried, this is just very simple, a model of arbitrary institution. And we can use many different types of equations, but I just went by these 2 equations. And I found, even with these 2 simple equations, I found interesting results. So in the first equation, basically, if the last income of the agent is greater than one, let's say, randomly generated number, then that agent is going to receive the tax return by the central planner. And then the tax return that agent is going to be received is that it is not a fixed number. It is a kind of random number based on the second equation, which is going to basically transfer from the central planner to that agent. Basically, again, I emphasize on 2 factors. Not all agents are going to receive the tax return. And at the same time, even those agents which are going to be considered to receive the tax return, they are not receive the equal tax return. Each one of them receive a random amount of tax return. So then, just based on these very, let's say, simple model, that again, the plots on the left shows the, let's say, the environment which is more similar to, let's say, Iran, to the condition in Iran, isolated patches of natural resources. And the plots on the right shows more, let's say, those countries which has more favorable environmental condition, and the natural resources are distributed evenly. So what I observe is that even with this simple model, we observe, for example, if you just check the section C on the left plot and the section C on the right plot, basically the force plot from the left, the coin, and the force plot from the left again, the coin plots in both plots, which I mentioned on the left and on the right, the coin plot. Just with this simple model, we observe that under the for example, in the, let's say, band like in the environment with more isolated natural resources, at some point during the simulation, the agents are not able to increase their wealth. and they are just going to freeze. The amount of endowment that they have, they are just going to be freeze. But on the other hand, on the right side, when you just see the coin plot, that the agents are going to increase their amount of money across the steps of the environment. Basically, in this plot, this is just going to summarize what we obtained in this simulation. So even that the amount of natural resources in both environments are the same, the productivity is higher under the environment which has more uniform distribution of natural resources. The quality is less, but the maximum is also higher. So, and considering the fact that the amount of total natural resources in both environments are the same, and also the central government in both cases are arbitrary. The only differing factor among these two conditions is that the way that natural resources are distributed in the environment. So this is the final result of the project. Basically, I guess it is the most important result. I ran these simulations 4 times for the, let's say, for the environments with isolated natural resources on the top, and for the environment with more distributed natural resources on the bottom. And I discovered that in the more, let's say, isolated, in the environment with more isolated natural resources, at some point, the total tax return to all agents is going to be equal to 0. Basically, all agents are going to receive just 0 amount of tax return from the central government. But on the other hand, in the environment with uniformly distributed natural resources, we see that two different things we observe. First of all, the agents are not equal in front of the central government. They are going to receive different amount of tax return. The second is that the tax return that they receive is different. And basically, we can say that there is a kind of social classes. In the top row, we don't have any social classes. But in the second row, we see that in the blue row, we see that the agents are going to be different in front of the central government. And we observe, for example, social classes in this environment. This is the second project. Now I am going to explain the third project. A multi-agent reinforcement learning, a study of evolution of communication and teaching on the Libertarian and Utilitarian governing system. Basically, this was the project by this project, I was introduced to Foresight. And there are many things in the literature that talking about, for example, the value of communication in math, in multi-agent reinforcement learning, and also in human experiments, particularly related to social dilemmas. For example, in math, it has been shown that communication can enhance exploration, maximize reward, and diversify solutions in complex optimization simulations. In human experiments, it has been shown that costly punishment has positive effects on resolving common pool resource dilemmas only when it is combined with communication. Moreover, human experiments show that the essence of communication, even without any enforcement, is more effective than the content of the communication in facilitating cooperation in social dilemmas. Several possible mechanisms have been proposed, including communication might allow coordination among participants, thus they might develop trust relationships, and communication might express social pressure. In this project, communication and teaching are modeled through, in this project which I have done, communication and teaching are modeled through 2 simple variants of signaling game, a game which was originally devised to simulate the emergence of convention. In game theoretic words, a convention is a system of arbitrary rules that enables 2 players to share meaningful information. Moreover, as a post-processing step, I use the same model of morality which I developed for the first project here to compute the effects of language alignment, because the main purpose of communication was to have aligned languages. So I wanted to test that what is the effect of language alignment on the various governing system on the morality of the agents in the environment. So here I just bring the modification that I made to the original AI economies. Here I made basically 2 different environments: the modified AI economies with communication and the modified AI economies with teaching. So Again, we have 4 material resources, but this time we have 2 house types. Each one of the houses is going to be built exclusively by 2 material resources. Then in the environment with communication, the agents can build houses together or can build alone. If they want to build houses together, they have to align their language, and their language is to be aligned by communication. For example, at the initial step of the environment, their languages are the kind of letters that they use for naming different material resources are totally different. Then, as long as the environment is going to move forward, the agents are going to communicate more, and their languages, basically the letters that they use for different material resources in the environment, are going to be the same, are going to be similar and similar. And finally, their languages are going to be completely aligned. This is the case for evolution of communication. Then for the evolution of teaching, basically, there are 2 sets of agents. In both cases, in the environment for the evolution of communication, I have 6 agents in the environment. And for the environment with the evolution of teaching, I have again 6 agents in the environment. But for the environment with teaching, basically, there are these 6 agents are going to be divided to three agents, two sets of 3 agents. So the first set of 3 agents, they are teachers who know how to build houses, who know, for example, how to combine different material resources to build one house, but they are not able to do that. Then on the other hand, the other 3 agents, which are the students, they don't know how to build, but they can build if someone teach them. So the task of the teachers is to teach the students to learn, to know how to build these kind of houses, and then they build these houses. Again, I use the same voting mechanism which I explained before here to basically to have 3 different governing systems: full libertarian, semi-libertarian, utilitarian, and full utilitarian. And the final 2 taxes are going to be basically invested on the material resources depending on the governing system. The only action which was added in this environment is communication and teaching. And yes, this is the only action beside, for example, vote and invest, which was added before to this environment, to the AI economy's original framework. This is the first result, evolution of language alignment. So basically, what I obtained here is that, first of all, in the environment with communication, which the agents can build houses together or alone, they somehow, the event of, for example, building houses together is very rare. And the reason for that, because their reward, because their languages are completely misaligned, so there is not that much reward associated with, for example, just communicating with each other when you cannot build houses. So this is the reason why under this environment, basically the plot on the left, the complete alignment of languages did not happen until the end of the episode, and for all 3 governing systems. But as I said, the communication happened, and the alignments somehow, for example, improve, but it does not, we don't see a complete alignment. But what we observe on the left plot is that under full utilitarian governing system, we have more communication rates, and also we have more alignment, language alignment. Again, for example, communication rate is completely correlated with language alignment, because as far as the agents are talking more and more with each other, they are going to have more aligned languages. So on the plot on the right, we see that under the teaching, basically under the environment with teaching, we observed that for all 3 governing systems, full libertarian, semi-libertarian, utilitarian, and full utilitarian cases, we reach to complete language alignment. Because in this environment, the only way that the agents can build houses, it is that the teachers basically teach the students how to build the houses. There is not any other way that, for example, somehow they could build houses. Again, in this plot, we see that under full utilitarian case, basically the green line in both plots, we have more communication rate, and based on that, we have more language alignment. So Now, maybe, I don't know, maybe for some of you, this is a bit surprising result. That's why, for example, under full utilitarian government, we have more language, we have more communication rates and language alignment compared to full libertarian case. So one speculation which I have is that basically the full utilitarian governing system, if you remember, it is the only governing system which we don't have any direct voting. Basically, the agents are not able to vote. And the central government is going to decide to rank the material resources, and then basically is going to divide, to invest the total collected due taxes on those material resources. So if we consider voting mechanism as a kind of, for example, communication channel, what we observe on the full utilitarian case that there is not any communication channel in the environment. So maybe this is the reason that on the full utilitarian case, the agents are using, for example, the other type of communication, which is a device for this environment here. And so to develop some kind of communication channel. This is one speculation which I have, and probably it is possible to test this kind of hypothesis more with other experiments. So then I wanted to see that what is the effects of, for example, a language alignment on morality or fairness of the agents. So again, we have the plots on the left, we have the plots for the environment with communication, and on the right, we have the plots for the environment with teaching. So if you remember the non-zero alpha, basically the alphas and betas coefficient from the inequity aversion model refer to disadvantages in equity aversion coefficients. And if they are higher, it shows that agents are more disadvantageous in equity averse. They are more fair in this respect. And the betas refer to advantages in equity aversion. If they are higher, the agents are more fair and moral. In this respect, they are more advantageous in equity averse. Again, if you remember, here basically the only environment which we have a fully converged language alignment is the environment with teaching. So I believe due to this fact, if we just consider the plots on the left, on the right, in the environment with teaching, basically the number of non-zero alphas, the number of non-zero betas, basically the disadvantages in equity aversion coefficients and the advantages advantages in equity coefficient, they are going to be correlated positively with language alignment, which is again not that much surprising because we expect that as far as the agents are going to communicate more and their languages are aligned, they are going to be more fair, more moral, and more cooperative with each other. Then this is the final part of this project. So I wanted to see that what is the effect of language alignment on productivity, equality, and maximi. Again, I believe that it is more fair to consider only the environment with teaching because the language alignment in that environment converge to basically to the full, basically the language in this environment converge to the full alignment. So again, here we see that there is a correlation between equality and language alignment. Basically, on the left, on plot, the three plots on the right and the plots in the middle. The equality is somehow positively correlated with language alignment, but at the same time, the productivity and maximi they are negatively correlated with language alignment, which probably is possible to, for example, discuss more about what was the reason behind these kind of, for example, observations that we have. Then future projects, I am in the midterm basically now. I am now using a generative agent-based framework. The framework which I use is Concordia framework developed by DeepMind. It is a very recent framework to stimulate social phenomena. Basically, I am trying to ask similar questions and to see that what I can obtain from this generative agent-based framework. Generative agent-based frameworks is that instead of, for example, multi-agent reinforcement learning, we have we have large language model agents, which they talk with each other. And in the long term, I am planning basically to apply these multi-agent reinforcement learning, let's say, frameworks and generative agent-based models to real problems in one. Let's say there are a few differences between multi-agent reinforcement learning and generative agent-based models, and it is argued that the agents in generative agent-based model take actions by answering the following questions: what kind of person am I? What kind of situation is this? And what does a person such as I do in a situation such as this? So basically, they are not rational utility maximizer, and they are not reinforcement learner. By this, I want to conclude, and I want to thank basically all my colleagues at different institutions, and also thank you for your attention, and hope that, I don't know, maybe we can collaborate more on these projects.
Fantastic. Thank you so much. That was a lot to digest, but really interesting stuff. And I love the different analogies between just, human evolution of cooperation and developments of different cooperation frameworks and how they could work with AI systems. That was really cool. Thank you.
Thank you.
Questions, comments in the last 4 minutes. If you guys want to raise your hand, that might be better, because I know that there was a really interesting chat conversation going on, but I don't know if any of the questions are actually for Aslan. So if you have a question for Aslan, now is a good time to raise your hand, basically. We'll probably get to 1 or 2.
Sorry, I can't find the raised hand icon, but I figured I'll just talk. Hi, Aslan, thanks for sharing your research. It's so cool to see using reinforcement learning to understand like complex social phenomena. One thing I was really curious about, so like I train agents in multi-agent RL settings, and I find that their behaviors it takes a lot of work to get an agent to do anything interesting yet, or even close to what you would say is like a reasonable policy. So it takes trying lots of different model architectures, doing like large hyperparameter sweeps. Often I have to train over millions of episodes. And if I don't do that, like the agents do stuff, but I wouldn't say they're doing anything like that intelligent. They'll go and get resources and use them or something, but you can clearly see they're doing really stupid stuff and are not doing obviously like very obvious smart stuff. I'm curious, in your setup, like how do you know that these agents are actually learning smart, like good behaviors, instead of just like learning some very basic behavior and then we're generalizing from that?
So I would say that one limitation of my studies probably it is the number of iteration of the environment, of the steps of the environment. But even with this, let's say, limited number of steps, I would say that it was not that much difficult to obtain, let's say, some results which somehow corroborate some kind of hypothesis, well-established hypothesis in the literature. I cannot say that, for example, the environments converge to final solution. This is very difficult to say. But I would say that even with this limited number of environmental steps, I observe some interesting, let's say, behavior. But I cannot say, for sure, I cannot say that this is the point, let's say, the final equilibrium solution. This is very difficult, say, in multi-agent reinforcement learning.
I'm really, like, from looking at your paper, it looks like you trained for 5,000 episodes.
Yes, that's true. That's true.
For me, it takes millions of episodes. If I train for 5,000 episodes, the agents are no longer doing random stuff. They can walk up and get a resource or something. But it takes me millions of episodes before, when I visually examine what the agents are doing, they're doing anything that's better than random. So I guess I'm like,
yeah, you use the same framework, or you use the same environment, or you use different environments. So I don't know.
Different environment, different framework. I don't even know what your neural architectures are. But I think that's my point, is that it seems like you can get, you can do a little bit of training and get an agent that does something, and then you're making conclusions. But it seems like you first have to study the actual agent's behavior and be like, oh, okay, did it actually learn how to behave in this situation? Is it behaving in reasonable ways before you can look at emergent phenomena?
Yes. So for sure, I would say that there is a kind of, because of the, for example, computational resources that they have, there is a kind of limitation on the amount of, for example, the steps that I took in these simulations. But I would say that at the same time, with this amount of simulations, I observe some interesting behavior from the agents. But again, I cannot say that these are the final equilibrium solution of this environment. Maybe these are not. Maybe if I run, for example, for 1 million steps, I observe a different, for example, solution, which is different, totally different. But this is, as far as I know, this is very difficult to say in, for example, in any kind of multi-agent reinforcement learning. This is difficult to say.
Hey, you guys, unfortunately, we're 2 minutes over time. I want to be mindful of everyone's time here. Thank you so much, Aslan. I'm so happy that it finally worked out, that we got to present, even if it's just virtually for now. But I really appreciate you coming on. I appreciate the chat a lot. That was a really interesting discussion. Yeah, lots to digest. Thanks a lot for your fantastic work. And it definitely has implications for both AI and social science. So thanks, everyone. Have a good one.